Hi everyone. Last lesson was extremely important as it showed the foundation of how to make a system of linear equations. Equally important, though, is how to solve such a system once you've made it. There are three main ways we are going to use to solve systems of equations: graphing, substitution, and elimination. In the end, it will not matter greatly which of these three methods you use. Each method has positive and negative attributes, and you must decide which is best for you. That being said, there is a certain algebra component that you have to meet the curriculum outcomes for grade 10 math. Basically, you can't just graph everything on your calculator. However, certain types of equations are better suited to each of the above methods. For instance, if a question is set up for elimination and you try to use a graphing method, you'll actually do more work to rearrange the equation so you can graph them than you would have done had you just done elimination. Okay, we're going to come back to the other methods later. For now, our focus is on graphing. So, part 2, solving a system of linear equations graphically. Okay, the solution of a linear system can be estimated by graphing both equations on the same grid. If the two lines intersect, the coordinates x, y of the point of intersection are the solution of the linear system. Okay, so if we graph these two equations on the grid and find the intersection point, that'll be the solution. So let's give this a try. We can turn these both into y equals mx plus b. Right now they're both in standard form. Okay, but remember, we learned how to graph standard form here in chapter 6, so we might as well just leave them as is. So 3x plus 2y equals negative 12. Now remember, how we do this is we find the intercepts. So if I find the x-intercept, remember that happens when y equals 0. So we get 3x plus 2 times 0 equals negative 12. Well, 2 times 0, of course, is 0. So then 3x equals negative 12. Divide by 3, and x equals negative 4. Okay, so when y is 0, x equals negative 4. 1, 2, 3, 4. Make sure we try and get it right this time, the first time. Okay, then the next one, the y-intercept, remember, happens when x equals 0. So if we go up to the equation, 3 times 0 is just 0, so we don't even need to write that part. So let's just write the 2y equals negative 12. Okay, then divide by 2, and y equals negative 6. So that is a y-intercept, so when x is 0, y is negative 1, 2, 3, 4, 5, 6. Okay, so there is our 2 points, and I can just draw a line between, I should be a little closer than that. Okay, there we go, that's pretty good. Awesome. Okay, so that's the first equation. The next one, so the negative 2x plus y equals 1. Okay, so the x-intercept, so it happens when y equals 0. So negative 2x plus 0, so we won't even bother writing that, so 2x plus 0 equals 1. Okay, divided by negative 2, divided by negative 2, and x equals negative 1/2. So when y is 0, x is negative 1/2. Okay, well that's about there. See how we said we can estimate it? Now hopefully, well, I know this one works out really nice, but anyways, let's just go with it. Okay, so then the y-intercept happens when x equals 0. Sorry, that's a y. Okay, so x equals 0. So then negative 2x is 0. So you get 2y equals... Ooh, wrong equation. Funny. Okay, so y equals 0, or so y-intercept, x equals 0. So negative 2 times 0 plus y equals 1, so 2 times 0 is just 0, so then plus y equals 1, or just y equals 1. Okay, so when x equals 0, y equals 1. Wow, that's a tricky one to graph. The points are really close together. Okay, but let's just graph those and see. Oh, look at that. They do work out quite nice. So the intersection point, here I should draw and make a different color. I'll use orange. So the intersection point of the two graphs is right there. Intersection at, okay, so let's see, -1, -2, and -1, 2, 3. So x is -2, y is -3. Okay, so that is the idea. How to graph these things. So I get it back to 100. There we go. Okay, so we find the intersection point. It's at -2, -3, and awesome. Okay, so that is the solution to this this system of linear equations. Okay, and another way of to graph this is to use your graphing calculator. In fact, for graphing style problems, using your calculator is faster and doesn't require any special graphing paper. Changing the scale of your calculator or your graph may be necessary, and it can be tricky, but we'll make it work. It's not that hard. Okay, just to be clear, this is not a graphing style question. Okay, we can make it one by rearranging both formulas to the slope-intercept form, y equals mx plus b, and then using our calculators. That is what our calculators graph, mx plus b. Okay, a true graphing style question already has both equations in y equals mx plus b form, or y equal form. We will also graph stuff that has, n equals something for both equations. Those are nice graphing equations. For now, it doesn't work out like that, but that's okay. So, what I want us to do now is let's just play a game. Let's take those two formulas above and turn them into y equals mx plus b. Let's just have a quick look and we'll play. Okay, so let's see. We'll have 3. Oh, got my eraser on. Okay, there we go. 3x plus 2y equals -12. So remember, if we want the y all by itself, I have to get the x to the other side. So 2y equals -3x minus 12, and then divide by 2. So then y equals -3 halves x minus 6. Okay, so there's my one equation. Okay, then the other one started out as -2x plus y equals 1. So plus 2x plus 2x. So y equals 2x plus 1. So there's the other equation. So those, once we have those two equations in y equal form, now we're going to graph them on our calculators. Okay, marvelous. Okay, so there's two different parts to this video. I'm going to start with the TI Inspire users. Okay, if you have a TI 83 or 84, feel free to fast forward this video to the next page, because that's when I talk about a TI 83 or 84 calculator. Okay, but for now, we're going to talk about the Inspires, so away we go. Okay, so I want you guys to start a new graph page. Remember, I don't teach using the scratch pad, so we showed you how to do this a while ago. So if you have been using them, start a new document first. Okay, so you press the home button. Okay, then press 1 for a new document. Okay, and if you had a document going, it'll ask you if you want to save it. Just say no. Okay, to the current document, it's not a big deal. Okay, and then we're going to add a graph page. So we've done this before, but that's okay. Tell you what, let's just, really quick, go to the calculator here. Okay, so you can see my calculator. Okay, so if you just press the home button, wow, it's dark today. Okay, there we go. So home button, and then the new document is the first one, so new document, enter. Okay, and then just say no to saving. It's really not a big deal. Okay, and then add a graph. Okay, awesome. You can see that the entry line is visible right there, f1 of x. So all we're going to do, now that we have that, is we're simply going to graph our two equations. Okay, right, if you've already were on a document, you can just go control, so here's the control button, control and then plus page, or control doc. So that gets you to that menu, so then you can just add another graph if you already had a document open. Okay, and we can toggle between, see how that says 1.1 and 1.2? Those are like file tabs or pages in our graphing document. So if we go control left, Okay, now that accesses 1.1. If we go control right, that accesses page 1.2. Okay, so might as well start at 1.1 because, whatever. It's all good. Okay, so f1 of x. So now that we have that entry line, I'm going to graph. So it's y equals negative 3 halves x minus 6. So really, we can just go negative 3 divided by 2. Okay, then type in x. Now, x is way down here, so x. Okay, focus again. 3x plus 2, and then minus 6. Hit enter, and it graphs. So that looks a lot like the graph we had from the other page. Now, notice that you can't just type in another equation here. It's kind of crappy, but if you hit the tab button right there, hit tab, hey, your entry line is back. Okay, and it automatically goes to the next graph, f2 of x. Ooh, sorry, my bad if this doesn't stay on there for forever. Okay, anyway, so f2 of x, so we want to graph the second equation. So remember that was 2x plus 1, so 2x plus 1. Okay, focus, there we go. Hit enter on that one, and oh, look, it's the other line. Now you can see the intersection point, but the thing is, it's not good enough just to see the intersection point. Like, we can count, but it doesn't always work out nice. So we can force our calculator to tell us the intersection point. So hit the menu. Everything good is under the menu button. So menu, and now what do we want to do with this graph? Well, the menus are kind of specific, so we want to analyze the graph. We want to do something with it. Okay, so that's menu item 6, and then intersection is number 4. So for next time, we could just go menu 6, 4, and it would get us right to here. Okay, now your calculator prompts you, it says lower bound. So see this dotted line? It wants us to put that, so there's the point we want, right there, and so it wants us to select a boundary that is lower than that point. So once I get lower, and all I did is I just scrolled with the little pad here, okay? So you get to anywhere to the left of the point you want, so that's lower, okay? And then hit enter, and then it prompts upper bound. So that's the upper boundary. So if you scroll it sideways, look, now it's going to search for the intersection point of that shaded area. So you just have to go this way. Now look, as soon as you cross that intersection point, it kind of guesses at it. So if you hit enter, look what happens. That point now becomes solid, and you can see, oh, look, it's -2, -3. Now, you see what I did? I grabbed it with the grabber. I hovered my cursor over that and then pressed the center button, and the hand closed on it. So now I can just, see, I can just move it out of the way and hit enter to release it. Great. So the intersection, okay, come on, focus. So -2, -3. Awesome. So that is how you use the TI Inspire to find an intersection. Again, if we go menu 6, 4, it just gets us right to that point. Again, lower bound, enter, upper bound, enter, and then there's the point again. Okay, awesome. So that's how you use the calculator for that one. And don't worry, we're going to practice this lots. Okay, so now I'm back to the main screen. So now we're going to do exactly the same thing with the TI-84 family calculators. Okay, so I just have to do a couple of things before I get this going. Okay, perfect. So clear. All right. Get the camera back on. There we go. Here's my TI-83 Plus. Okay, again, it doesn't focus all that well. I'm so sorry. Okay, now to graph on these things, just hit the Y equal button, just like we did before. And that last equation that we graphed way back in chapter 6 is still on there, x squared minus 2. So we can just hit the clear button. It goes away. Okay, so again, our first graph that we wanted to graph was -3 divided by 2. Okay, and then press the X button. So the X button is like right there, xt theta n. Okay, so -3 over 2x minus 6. Okay, so that's awesome. Now, if we do that, okay, so that's great. Graph that guy. Oops, sorry, I'm Blair Witching all over the place. Now, on the TI Inspire, we actually have to graph both of them separate. On this one, we can just graph them both at the same time. So it was 2x plus 1, 2x plus 1, and then I can hit the graph button right here. So if I hit graph, both graphs show up at the same time. That's kind of nice. Now we can just count off there, but again, our calculator is more advanced than that. So look, I'm going to drop in here. Right above the trace is the yellow letters calc. Now, depending on your version of calculator, your second button might be blue, it might be green, whatever. So mine is yellow. So to access these yellow buttons, I have to press the second button first. So I'm going to go second trace, which accesses the calculate menu of the TI-83. Now, if you have a look at the choices, value, 0, minimum, maximum, and intersect. So we're going to go right down to number 5, intersect. Now look what it asks. Come on, zoom in, come on. It asks, whoop, timed out, okay? It asks for the first curve. Now really, if you have two graphs, only two graphs on the grid, y1 and y2, then this part is really easy. So I'm going to recommend that you always clear your graph and just have the 2 in there. Okay, so really the first curve is on there. Okay, so once you hit enter, it'll say second curve. So it'll put the cursor on the second curve, so you hit enter. And then it'll say guess. So you hit enter again. So the intersection you can see is -2 and -3. Okay, so that is awesome. Now that's also on your page here. Okay, so there's notes, but this is just better. Okay, so tell you what, let me, it's going to time out on me here anyway, so I'll just go back to here. Okay, so if I just hit clear on that, then it goes away. So let's just do this really quick. So second trace, okay, intersect, so I can press the 5 key to get to intersect. And then look, it says first curve. Wow, very blurry. I'm so sorry. Come on, focus. Focus. Sort of. So you just go enter, enter, enter as fast as you can. 1, 2, 3. And oh, look, there's the intersection. -2, -3. Perfect. Okay, so that is how you find the intersection on a TI-83 or 84. Okay, super easy and be really helpful for anything graphing. Okay, so we need to cancel that so we can keep saying that. Okay, sorry guys, I need to put that down. Whew. Okay, so anyways, that's how we graph with the TI Inspire and the TI-83-84. Now, of course, what happens, you need them both in the right form, okay, and yeah. All right, so moving on. Example number 1. Okay, so if we have a look at the next page, sorry. Okay, example 1. So solving a linear system by graphing. So solve this system by graphing on your calculator. Okay, so all we have to do, okay, we have to turn these into y equals mx plus b form. I'm forcing you to graph it. These ones are actually set up for elimination. Haha, funny thing. Okay, but we're forcing you to graph for these ones. Okay, so this one, the 2x is going to come over, so 3y equals -2x plus 3, right? The 2x just comes over, and then we divide by 3. Okay, so then you get y equals -2/3 x plus 1. Okay, so that's our first graph, our first equation, and then the second one, okay, let's see, if the x goes across, we get -y, so if the x moves across, we get -x plus 4, okay, and then we have to divide by -1, because our calculators don't graph negative y's, they just graph y's. So y equals, okay, so the two negatives cancel, and you get x minus 4. Okay, so there's the other graph. So we just follow those same procedures on our calculators. We graph both of those equations. Okay, on the TI Inspire, I would say erase the other two graphs or just make a new graphing page, right? That's control plus page or control doc. Okay, for the TI-83-84s, just go to the y equal menu and clear those first two graphs and then just put these ones in their place. Okay, so then graph and then find the intersection, and that works out to 3 -1. Okay, and that's really how you show your work for a graphing question too. Sometimes they ask you to sketch what the graph looks like on your calculator. I'm not going to make you do that right now, but that is a possibility later on. Okay, so either way, so if we try this for b, again the x comes across, so y equals -x plus 8. Okay, and then let's see. When the y is negative, it's kind of a handy little trick to move it over and then the 14. So we get 3x minus 14 equals 2y. See, the y is now positive. So then when you divide by 2, you don't have to worry about the negative. So then y equals, so 3 halves x, and then 14 over 2 is -7. Okay, so there is the second equation. So then we graph both of those on our graphing calculator. Okay, and when we do that, and then follow the procedure from the last page for the intersection point, okay, we get an intersection point of 6, 2. Okay, now the only rule or thing that you might have to worry about is changing the windows. Okay, and then the next example actually shows kind of how to do that. So, okay, example 2. So one plane left Regina at noon and to travel 400 miles to Ottawa at an average speed of 400 miles per hour. Another plane left Ottawa at the same time to travel to Regina at an average speed of 350 miles per hour. A linear system that models this situation is, so d equals 1400 minus 400t, and d equals 350t, where d is the distance in miles from Ottawa, and t is the time in hours since the planes took off. Okay, so look, this one is a true graphing scenario because they're both d equals. Okay, now remember, your calculators don't graph d's and t's. So really, we're going to graph y equals 1400 minus 400x, and then y equals 350x. Okay, but we know that our x's really, or our y's mean distances, and our x's mean times. Okay, so we just have to convert in our heads, and it's not a big deal. Okay, so we're going to graph this system on our calculator. Okay, now when we do that, so I'm going to graph it really quick on my calculator. You know what? I should show you this one more time. Okay, so we'll do that here. Okay, so this is on the Inspire. Okay, so if I go control doc, which is plus page, so then I can add a new graphing page. Okay, poof, there it is. Now it starts at F3 because F2 was already on that other graph in F1, so I don't have to worry about that. I just graph from F3. So it's 1400 minus 400x. Okay, remember you're graphing y's and x's. F of x is just y. Okay, so you graph that. Okay, and then hit the tab button, and then we're graphing 350x. So 350x. Remember, I hit the tab button to get the F4 of x. Okay, awesome. Now, ooh, those lines look like they're straight up. It's really weird. Okay, remember, the graph only goes up to 6.67. Okay, that's really weird. Okay, so remember, the menu button is kind of all important, so hit menu. Okay, so if we go to number 4, which is Windows Zoom, okay, the very top one in that one is the Windows settings. So look, the X minimum is 10, the X maximum, sorry, X minimum is -10, X max is +10, the X scale is auto, so it just kind of figures out what it thinks. Okay, so the Y minimum is -6.66, the Y maximum is +6.66. Now, the question itself says the planes are traveling 1,400 miles from Ottawa to Regina. So the thing is, I can put 1,400 for, I'm just scrolling down, so down button. Okay, I can put Y max is 1,400, but the thing is, that's going to be right at the top of the grid then, right? Because that's the exact distance. So let's give us some space. So let's guess 2,000. Oh, timed out on me. Okay, so if I guess 2,000, okay, and then it'll just, the scale will auto it. Not a big deal. So if I hit OK, Oh, look what happens. So see up here, my Y scale, my Y maximum went up to 2000, and look, you can clearly see the intersection point now. Okay, so now we do that same procedure, menu 6-4. So menu, analyze, graph, intersection, lower bound, upper bound, okay, poof, boom, and look what it says. 1 point, okay, I'm going to try and grab that. Come on, grab that. There we go. So I can move that out of the way so it's not. Okay, so 1.87 and 653.333. Okay, so I'll tell you what, 1.87. Okay, so go back to here. Okay, so the intersection point was 1.87 and 653, and I think it was like 0.333, but that's fine. Okay, now what does this mean? Okay, well, remember, this is the x and that's the y. Okay, well, the x coordinate, that was our time, and our y coordinate was the distance. Okay, so the 1.87 is a time. So it's 1.87 hours that they intersect after, and they are 653 miles away from Ottawa. So that's what these mean. The planes cross paths. Now, not too close, of course, because we don't want to have a crash in aerospace, but can cross paths at 1.87 hours, 653 miles away from Ottawa. Awesome. So that's how we graph those. Very similar process to the with the TI-84, but you know what? We should maybe talk about when changing your windows on the 83, 84. Okay, so here we go. Here's the thing. Turn it on. Okay, so again, let's just clear those. Okay, and then it's 1400 minus 400x. Okay, and then 350x. So we graph those. So graph. Again, you can't see anything, or at least very much. Okay, now for us, on this one, we have to go to window. Okay, so the window button right there beside the y equals. So then it's the same kind of idea. X min, X max, scale, Y min, Y max. And remember, we made the Y max up to 2000. Now look, an 83, 84 doesn't have an auto scale. So look, if we leave it as a scale of 1, it will just get a really thick line on the y-axis. So a good way of thinking of this, so the y max is 2000, so if we make the scale 200, just take a 0 off, then it'll be 10 ticks and we'll be able to see it. Sort of okay. Okay, there you go. Okay, so that's that, and then of course second calc. So we want the intersection, and then enter, enter, enter. Boom. There it is. Okay, so exactly the same answer as before. I wonder if we can get that to zoom a little better. It doesn't look like it's going to play with us very well. Sorry, probably because I'm covering up the light. So 1.86666 and 653.3333. So you can see it's exactly the same stuff as the TI Inspire, and it's good. So, all right, thank you for bearing with us with the different calculators. I do appreciate that. All right, so moving on. Okay, so example 3. Okay, solving a problem by writing and then graphing a linear system. Okay, so that's not so bad here. All right. Okay, Wayne received and sent 60 text messages on his cell phone in one weekend. He sent 10 more messages than he received. So this is one of those table ones. We can set this up as a table if we really want, or we can just say, okay, so R equals the number of texts received. Okay, and then let's make S equal the number of texts sent. Okay, so he sent and received 60 in a weekend. So that means that R plus S equals 60. Awesome, that one's pretty easy. Okay, and then he sent 10 more messages than he received. Okay, so what that means is he sent 10 more than he received. So remember that word more? In order to be more or less than something, we have to start with a something. So 10 more than we received. Okay, so that's awesome. So those are our two equations. Look, this one's already set up for graphing. Perfect. This one, the first one, we have to rearrange a little bit. Not a big deal. Now, you can't just graph R equals because the other equation is in S equal form. So we have to move the R over and we get S equals negative R plus 60. Now they're both in the same kind of form. So remember, this is, I'll write in blue. So this is going to be Y equals X plus 10. And this is going to be Y equals negative X plus 60. Okay, so that's how we're going to graph those on our calculators. Okay, and we go from there. So we're going to graph these two things. Now look, we sent and received 60. Okay, so the thing is, if we make, so we maybe sent 60 text messages or we maybe received 60 text messages. So really our maximums are going to be 60 on both the X and Y axis. So if I go up to 80 for each, so X max, if I make that 80 and I make the Y max 80, we'll be able to see it no trouble. Okay, so we do have to play with the windows a little bit for these things. So anyways, those are our systems. I want you guys to graph these now. And then the question is, how many text messages did Wayne send and receive? Okay, so I'm just going to graph these things super, super quick. Okay, so there we have it. And you end up with a graph that kind of looks like this, and kind of looks like that. So you get an intersection point. And that worked out to, okay, so it is 25, 35. And now we have to interpret what that means. Remember, this is an X coordinate, that's a Y coordinate. And our Y coordinates we said were S's, and our X coordinates we said were R's. So I received 25 text messages, or Wayne received 25 text messages, and he sent 35. So usually with word problems like this, it's never a bad idea to write a sentence. So Wayne received 25 texts and sent 35 texts. There we have it. All right, guys. So that's it for this section. I know it was kind of a long one with showing you how to graph like that, but I think it's worth it. And I'm sorry, I know you only have one kind of calculator, and we bounce back between both. But hopefully you have an appreciation of what the other people have to do now too. So it's all good. Anyways, this is section 7.2 in your textbook, starting on page 409. Okay, remember you can print the questions off the workspace card, because then you can write all over them. It's all good. Okay, make sure you show your teacher your completed work when you're done, and we'll go from there. Thanks, everyone. See you next part.